Given a polynomial function f, evaluate f of x at x equals k using the remainder theorem. Now, step number 1, you're going to use synthetic division to divide the polynomial by x minus k. Step number 2, the remainder is the value f of k. Now, using the remainder theorem to evaluate a polynomial, use the remainder theorem to evaluate f of x, which is equal to 6x to the fourth minus x cubed minus 15x squared plus 2x minus 7 at x is equal to 2. So in step 1, to find the remainder theorem, using the remainder theorem, use synthetic division to divide the polynomial by x minus 2. So that means we're going to take 2 as the value of k, and then we're going to use our leading coefficients of our polynomial. So we have 6, we have negative 1, we have negative 15, we have 2, and then we have negative 7. So there aren't any missing terms. So we're going to bring down the value of 6. So 2 times 6 is going to give us 12. And so 12 plus negative 1 is going to give us 11. And 2 times 11 is going to give us 22. And 22 minus 15 is going to give us 7. 2 times 7 is going to give us 14. And 14 plus 2 is going to give us 16. And then 2 times 16 is going to give us 32. And 32 minus 7 is going to give us 25. So we can see here that the remainder is 25. Now in step number 2, okay, it's asking us the remainder is the value of f of k. So let's find f of k. So if we find f of 2, and then we're going to plug it into our function. So it's going to be 6 times 2 to the fourth power minus 2 to the third power minus 15 times 2 squared plus 2 times 2 minus 7. So let's plug it into our calculator. So if we want to find this, we're going to say, okay, 6 times 2 to the fourth minus 2 to the third power minus 15 times 2 to the second power plus 2 times 2 minus 7, and that gives us positive 25. So again, the remainder is 25, and so therefore f of 2 is equal to 25. And again, we checked our answer by plugging in the value of 2 into the function.